enters into the battery. Okay, so here current leaving the battery is I1 through E1. So same current will enter into the battery. Now current leaving the battery is I2. So same current will enter into the battery, that is I2. Yeah, today you have holiday, Amma?
Yes, sir.
Yeah, fine. Now listen. Then I will tell you how to apply the Kirchhoff law here. So to apply the Kirchhoff law, just note the points like this. Take this point as A, I'll take it as B, I'll take it as C, D, E, F. Now apply Kirchhoff law to the loop. What is it loop means? A, B, C, D, A. Okay, take the loop A, B, C, D, A. So to that loop, if you apply the Kirchhoff law, first, according to this loop, you have to move from A to B. In between A to B, there is no resistor, there is no cell. So leave that. Then we have to move from B to C because we consider the loop A, B, C, D, A. So move from A to B, B to C, C to D, D to A. Now if you move from A to B, in the path of AB, there is no resistor, no cell. In the path of BC, we have the resistor R2, we have the current I1 plus I2. We are moving from B to C. No, we are moving from B to C, and current is also moving from B to C. Then you have to take a negative or positive no, across resistor. Yeah. See, look at the previous thing. Across resistor, no, across resistor. If current is moving from A to B, so look at this. So if current is moving from A to B, we are also moving from A to B. Then the product of current and resistance is taken as negative. So here also, we are moving from B to C. No, we are moving from B to C. Okay, let us suppose we are moving from B to C. Current is also moving in the same direction. Then the product of current and resistance. What is the current means? The current here is I1 plus I2. The product of current and resistance. What is the resistance means R2 is taken as negative. Next, A to B we moved, B to C we moved. Next we have to move from C to D. C to D, there is no resistor, so need not to consider. Next we are moving from D to A. So we are moving from D to A. In the path of D to A, we have a resistor R3, we have a cell E2. Now listen, we are moving from D to A. Current is also moving from D to A. Understood this point? No? We are moving from D to A. Current is also moving from A to A, D to A. Understood this point, students? So current is also moving from D to A. We are also moving from D to A. So what is the current in D means? I2. So you have to take minus I2 into R3. I hope you understood this point. Because here we are moving in the same direction of the current. Therefore, you have to take minus. Then you are moving from D to A. In this path, we have a negative terminal, we have a positive terminal. So we are moving from negative terminal of the battery to positive terminal of the battery. For a battery or for a cell, if you are moving from negative terminal to positive terminal, see, for a cell, if you are moving from negative terminal to positive terminal, that is taken as what more positive. Therefore, plus I will take it as E2, which is equal to 0. Or you can write like this also. I1 plus I2 into R2 plus I2 into R3 is equal to how much more E2. Take it as equation number 1. Similarly, I will explain about one more loop. Look at the loop. What is that loop means? A, B, E, F, C, D, A. Observe this loop now. Look at that loop. A, B, E, F, C, D, A. Yeah. Shall I move? I'll explain this loop. Okay. Now listen. We are moving from A to B. So A to B, there is no resistor cell. Next B to E also. No resistor, no cell. Now you are moving from E to F. If you are moving from E to F in this direction, now we are moving from E to F in this direction. Clear? For suppose we are moving from where to where means E to F. 1 minute. 1 minute. Just 1 minute. Yeah, could you see students? Could you see the board?
Yes.
Now listen. We are moving from B to E, nothing is there. E to F. So please listen. So I am moving from E to F in this direction. I am moving from E to F in this direction. Okay, I am moving from E to F in this direction. And current is moving here opposite direction. Now here current is moving in opposite direction. Okay. Remember, when I'm moving from E to F, I have to cross battery, I have to cross resistor. So this is battery positive, this is battery negative. So you have to cross the battery. If you cross the battery, then you can take it as we are moving from positive terminal of the battery to negative terminal of the battery. Now, if you are moving from positive terminal of the battery to negative terminal of the battery, that is taken as minus or plus. Minus. Therefore, here you can write it as minus E2, sorry, E1, minus E1. Okay. And remember, across the cell, we are moving from where to where? Positive to negative. Across the resistor, we are moving from E to F. Current is moving from F to A. Therefore, the product of again current I1 into resistance R1 is taken as negative. Now, you have to move from F to C. No resistor, no cell. C to D. No resistor, no cell. D to A. If you move from D to A, okay, if you move from D to A, again one resistor, one cell is there, and current is also moving in the same direction. Therefore, you can write it as minus I2 into R3, and you are moving from negative terminal of the battery to the positive terminal of the battery. If you move from negative terminal of the battery to positive terminal of the battery, then you can take it as E2, which is equal to 0. Okay, then you can write like this one: I1 R1 plus I2 R3 plus E2 minus is equal to E1. Sorry, plus E1 is equal to E2. I'll bring this minus all these things to the right hand side. Did you understand this point now? Yeah. Then I'll give you one loop, students. You try to solve for that loop. Okay. So what is that loop means? Apply the Kirchhoff law to the loop B, E, F, C, B. Yeah, apply for that loop and tell me what will be the answer. Tomorrow, will you write the test on first two lessons combinedly? What more? Will you write combinedly? I'll give you one test. Yeah, fine. Because if you attend for more number of tests, it will be helpful to you. Is it done, ma? Anyone did for that loop?
minus E1 minus
Minus
I2.
E1 minus I1 R1 plus I1 plus I2 into R2.
Yeah, very good, very good. So you are moving from B to E, no resistor, no cell. Next, we are moving from E to F. If you are moving from E to F, there is cell. So, but for that cell, we are moving from positive to negative terminal of the battery. So, if you are moving from positive to negative terminal of the battery, it can be taken as negative, therefore minus E1. And we are moving from E to F, current is moving from F to A, therefore you have to take it as plus. That is I1, R1. And you are moving from F to C, no resistor, no cell. And you are moving from C to B, there is a resistor and current. Then you can take it as minus I1 plus I2 into this is R2 is equal to 0. Okay. So you can write like this. I1 plus I2 into R2 plus E1 is equal to I1 R1. This is the equation. Okay, students. If you're done with this, I'll go for the next concept.
Sir, in loop ABEFCDA.
What, ma?
Sir, in loop ABEFCDA.
A, B, C, D, A. Okay.
Sir, in that why I1 R1 is negative.
Y, I1, R2,
R1.
Y, R1, positive only, right? I1, R1 is taken as positive only, right? Which loop, ma? First loop, second loop, third loop?
Sir, second one second.
Second loop,
Yes.
sorry. It is plus only. Sorry, it is plus. Sorry, it is plus only. Therefore, it will be minus if we bring to the other side. Thank you. Done?
Yes, sir.
Yeah, shall I move to the next concept?
Yes, sir.
Right on the Wheatstonebridge. Okay. So Wheatstone bridge is the application of Kirchhoff law. Now, Wheatstone is the application of Kirchhoff law. This Wheatstone bridge is used to identify the resistance of unknown resistors. Now, this is used to identify the resistance of unknown resistors. So, like this. So, it consists of four circuits like this one, four resistors R1, and it consists of one more resistor here. This resistor is taken as, for example, R2. And from here to here, there will be one galvanometer. Again, from here to here, there is one more resistor, R3. And from here to here, there is one more resistor, R4. And it is connected to the external circuit of, let us take EMF as E volts or else V volts. This is the circuit diagram of a Wheatstone bridge. Are you clear? So this is the circuit diagram of Wheatstone bridge. Now please remember, it will works on the principle. So what is the principle means? It works on the principle of Kirchhoff laws. It works on the principle of Kirchhoff laws. Okay. Then construction. So what is the construction means? For example, the Wheatstone bridge consists of four resistors. Clear. So it consists resistors. Okay, it consists resistors R1, R2, R3, and R4. Okay, are connected as shown in figure. Okay, so I'll take this point as A, I'll take this point as B, I'll take this point as C, I'll take this point as D. Now, between points A and C, okay, so between A and C, now between A and C, okay, battery is connected. Please remember, between the points A and C, battery is connected. And similarly, between the points B and D, now between the points B and D, galvanometer is connected. Now between points B and D, galvanometer is connected. Are you clear? So it looks like a Wheatstone-bridge circuit. Now this is a Wheatstone-bridge circuit. Are you clear? Now I'll write the working and theory. For example, let us consider I is the current passing through the circuit. Now, for example, let I is the current passing through the circuit. Let I is the current passing through the circuit. So, what is the current through the circuit means I? Now, at point A, current will divides into two parts. Now, for example, I'll take this current as I. Now, at point A, current will divides into two parts. I'll take the current through resistor R1 is I1. Current through resistor R2 is, for example, I2. So, for example, if I take at a junction A, now if I take at junction A, current I is equal to I1 plus I2. I'll take it as equation number 1. Did you understand this point, students? Now, the current from I1, okay, or the current from the junction A will reach us to the junction B. I'll take this current as, for example, I1. From this junction B, current divides into two parts more. Let us consider current through the resistor R3. I'll take it as resistor R3. 1 minute. So I'll take it as resistor R3. I'll take it as resistor R4. Now please remember, current through the resistor I3 can be taken as R3 can be taken as I3. Let us take current through the galvanometer is Ig. Then according to the Kirchhoff law, junction law, current entering into the junction is I1, current leaving the junction is I3 and Ig. Now can you tell me at junction B, what is the current entering, what is the sum of current entering, what is the sum of current leaving? Yeah, tell me now. Current entering into the junction B is how much? Yeah, look at the figure.
I1 plus I2.
Yeah, current entering into the junction is I1. Now current leaving the junction is I3 plus IG. Take it as equation number 2. Okay. Now take at junction D. Now same figure, look at the junction D. At junction D, current entering into the junction D is, for example, IG, I2. So IG and I2 is entering into the junction D. And what will be the current leaving means I will take current leaving as I4. Now can you tell me at junction D, what is the sum of currents entering? Sum of currents entering is IG plus I2. This is the sum of currents entering. Sum of currents leaving is I4. I'll take it as equation number 3. Do you understand these points or not up to here?
Yes, sir.
Now, as already I told you, how much current leaves the battery, same current will enter into the battery. Therefore, finally, at a junction, not a junction C, you can write like this: I3 plus I4 is equal to I. I'll take it as equation number 4. Did you understand these 4 steps? Did you understand these 4 steps? Do you understand the
Sir.
4 steps, ma?
Yes, sir.
Now, shall I move? If you copy, then I'll move. Shall I move now?
Yes, sir.
Copied everyone? Yeah. Now listen. Now apply Kirchhoff law to the loops. I will tell you the loop, ma. So applying Kirchhoff law to the loop. I will take loop, ma. What is that loop means? A, B, D, A. Apply Kirchhoff law to that loop. And tell me what is the value. Yeah, tell me, ma. Apply to that loop and tell me what is the value. Yeah, applied, ma. A to B.
Minus I1 R1 minus IG plus I2 R2 equal to 0.
Yeah, very good. So we are moving from A to B. Look at this figure, students. We are moving from A to B, and current is also moving in the same direction. So then product of current and resistance is taken as negative. So I1 R1 is taken as negative. Next we are moving from where to where? B to D. So we are moving from B to D. Current is also moving in the same direction. Therefore, what is the current here means IG, and I'll take galvanometer resistance is G. Next we are moving from D to A. So we are moving from D to A, but current is moving from A to B, A to D. Okay, we are moving from D to A. Now we are moving from D to A. But current is moving from where to where? D to, sorry, A to D. Current is moving from A to D. We are moving from D to A. Again, the product of current and resistance, that is taken as positive. So I to R2. Why? Because means we are moving opposite to the direction of current. If you are moving opposite to the direction of current, then you have to take the product of current and resistance is negative. So this is taken as 0. Then you can write like this also. But then you can write like this also. I1 R1 plus Ig into G is equal to I2 R2. If you bring it to the other side, I'll take it as equation number 5. Now, in the same way, apply Kirchhoff law to the loop, okay, B, C, D, B. So this is the loop B, C, D, B. So for the loop B, C, D, B, if you apply Kirchhoff law, can you tell me? You already copied that circuit diagram. Just apply Kirchhoff law to the loop B, C, D, B and tell me what is the value.
minus I3 R3 plus I4 R4 plus IG into capital G equal to 0.
Very good, very good. Now we are moving from B to C. Now we are moving from A to where? B to C. So move from B to C. Current is also moving in same direction. Therefore, you can take it as minus I3 R3. Next, B to C is over, C to D. So we are moving from C to D. We are moving from C to D in this direction. Then current is moving from D to C in this direction. Then the product of current and resistance is taken as positive. Therefore, this can be taken as plus I4 R4. Next, we are moving from D to A like this. Sorry, D to B like this. Now we are moving from D to B like this. And current is moving opposite direction to it. Therefore, again, you have to take it as plus Ig into G, which is equal to 0. Then from this we can write, okay, I4 R4 plus Ig into G is equal to I3 R3. Shall I write like this? I'll take it as equation number 6. Okay, nothing is there. I brought I3 R3 to the other side. So for example, next point, this is most important concept in the entire concept. Okay, for example, under balanced bridge condition, please remember, for example, if the bridge is balanced, so what do you mean by balancing of the bridge? Means I'm going to explain now. If bridge is balanced, if bridge is balanced means upper part of the circuit and lower part of the circuit must have same amount of current flows. Then such condition is called as balanced bridge condition. So for example, if bridge is balanced, then look at the figure, potentiality B must be equal to potentiality D. Okay, if the bridge is balanced, potentiality B is equal to potentiality D. So if potentiality B is equal to potentiality D, what is VB minus VD value? 0, na?
Yes, sir.
Yeah, potential difference value is how much? 0. Then current through the galvanometer IG is equal to how much? 0. Do you understand this point, students? Then current through the galvanometer IG is equal to how much? 0. Hope you understood this point. So if current through the galvanometer IG is equal to 0, look at the equations. So from equation number 2 and 3, look at the equation number 2 and 3. From the equation number 2 and 3, how those equations will modify? Take substitute IT equal to 0. Then equation number 2 and 3, how it will modify?
I2 is equal to I4 and I1 equal to I3.
Very good. I1 is equal to I3. 1 minute. So you can write I1 is equal to I3. Am I right? and I2 is equal to I4. These are the two equations. Now tell me, then equation number 5 and 6. Now from equation number 5 will becomes how much? Now from equation number 5 will becomes how much? I1 R1 is equal to I2 R2. My I1 R1 is equal to I2 R2. Am I right, students? Because Ig is equal to 0. Take it as equation number 7. Similarly, from equation number 6, how to write that? I3 R3 is equal to, here again Ig is equal to 0. Ig is equal to 0. Then you can write it as I4 R4. I'll take it as equation number 8. Now divide equation number 7 by equation number 8. Now divide equation number 7 by equation number 8. So if you divide equation number 7 by equation number 8, what is equation number 7 means? I1 R1 is equal to I2 R2 divided by I3 R3 divided by I4 R4. But we know that just now we calculated I1 is equal to I3 and I2 is equal to I4. Then I1, I3 are equal means cancel these two. I2, I4 are equal, cancel these two. Then we have R1 by R3 is equal to R2 by R4. Or you can write like this also. R1 by R2 is equal to R3 by R4. This is the Wheatstonebridge condition. This is the Wheatstonebridge condition. Okay. Please note it down. Then I'll tell you some problems based on this. Is it done now? Yeah. So time is up again. You log in back. You log in back again. Yeah. Is it done now?
It's not getting the screen.
Oh, okay, sorry. Yeah, fine. So copy this. If you copy this, I'll go for the next part. Yeah, just give me 1 minute. Just give me 1 minute. Yeah, I hope you copied this. Yeah, now, I'll go for some example problems based on this concept. Okay. Now, what is the main use or advantage of this one is you can able to find out the unknown resistance and you can able to compare the resistance also. Okay, so I'm going for some example problems now. So where we can apply the Wheatstonebridge. Okay, so just I'll write one question. What is the effective resistance between? Okay, what is the effective resistance between A and B? Okay, now please remember, whenever current passing through that particular circuit is zero, you can neglect that part. For example, look at this figure. In this figure, current through the galvanometer under balanced bridge condition, current through the galvanometer is zero. If current through the galvanometer is zero, you can remove the galvanometer completely from the circuit. Okay. Now, in the same way, I'll give one circuit like this. So this is the circuit. So I'll take this resistance as, for example, 10. I'll take it as 20. I'll take it as 30. I'll take it as 60. So we have the circuit diagram like this. So effect and the in between, I will take it as 50 ohm. So what is the effective resistance between A and B? To do such kind of problems, first what we have to do means take the resistors here as R1, R2, R3 and R4. Now apply the condition, whether that condition is satisfied or not. What is that condition means? R1 by R2 is equal to R3 by R4. Just verify this condition is applied or not. So R1 is 10, R2 is 20. So 10 by 20, 1 by 2. That is equal to R3, 30 divided by R4, 60. Cancel 0 and 0, 3 ones are 3, 1, 2, 1, 2 is 2. Therefore, 1 by 2 equal to 1 by 2. So condition is satisfied. Bridge is balanced. My condition is satisfied and the bridge is balanced. So if the bridge is balanced, then you can neglect the middle part of the resistor. Now you can neglect the middle part of the resistor, this 50 ohm. So if you remove the 50 ohm resistor, then finally we have a circuit diagram like this. Now finally we have a circuit diagram like this. So this is the circuit diagram. Understood this point? No? So this is 10, this is 20, this is 30, this is 40. Sorry, 60. Okay. Now please remember, then upper two parts are in series and lower two parts are in series. No, lower two parts are in series. Then what is the effective resistance means? No, then what is the effective resistance means? Upper two parts effective resistance is how much more? 30 plus 10, that is equal to 40. And the lower two parts are again in series. What is effective resistance means? 20 plus 60, that is equal to 80. So this is the point A, this is the point B. Now, again point is 60, 40 and 80 are in parallel. Then what is the effective resistance means? No, then what is the effective resistance means? 1 by R parallel is equal to 1 by 40 plus 1 by 80. Then you can write 1 by resistance in parallel is equal to, you can write it as 40 into 80 and the numerator is 80 plus 40. That implies resistance in parallel is equal to 40 into 80 divided by 120. Cancel 0 and 0. 4 ones are 4 threes are, which is equal to 80 by 3 ohm. This is the answer. Okay, students. So nothing is there here. If the bridge is balanced, then you have to neglect the middle part. That's it. If you're done with this problem, I'll give you one shortcut which will be helpful to solve the other problems. Is it done now?
Yeah. Yes, sir.
Yeah. Now I'll give you one more example or a shortcut. You can use this as a shortcut or an example. Now I'll take the circuit diagram like this. This is R. This is R. This is R. This is R. This I'll take it as 5R. Okay. Now please remember here all the resistor R1, R2, R3, R4 is R whole name. Then according to the Wheatstonebridge condition, R1 by R2 is equal to R3 by R4 is balanced. So therefore you can neglect the middle part of the resistor. Okay, therefore you can neglect the middle part of the resistor. But one important point here I will tell you directly. For example, if R1 equal to R2 is equal to R3 is equal to R4, if all four are equal, okay, let us suppose that is taken as capital R. Are you clear? Then effective resistance between the four resistors is R only. Please remember. Then in such cases, don't do the problem also, students. Whatever will the value of R is the substituted value of R. Okay. For example, I'll give one example. No? I have some resistors. For example, this is 1 ohm or else 1 minute. Here, like this. So I'll take the circuit diagram like this. I'll take the circuit diagram like this. So this is point A, this is point B. This is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ohm. And in between we have one more resistor, 5 ohm. Now what is the effective resistance? What is the effective resistance between A and B? What is the answer?
1 ohm.
Yeah, 1 ohm. That's it. Okay. So in such cases, need not to do the problem, friends. What will be the R value? That is the answer. Now I'll give you one more example problem based on this Kirchhoff law. Okay, so just look at the figure. I'll take this resistance as, for example, 5 ohm, and I will take this resistance as, for example, R. This is also R, or else I'll take it as 5R. Okay, this is point A, and from here we have one more R, and here one more R. Again, I'll draw one much more clearly. I'll draw much more clearly. So I'll take it as 5R. So I'll take it as point A. I'll take it as R. I'll take it as R. And I'll take this resistance as R. And I'll take it as R. Now these two are connected to point B. Okay. Now what is the effective resistance between A and B? But then what is the effective resistance between A and B? Yeah, please try to solve it. Yeah, please try to solve it, anyone. Yeah, did anyone? Yeah, nothing is there in this problem. Hold the point A. Now hold the point A and stretch like this. If you hold the point A and stretch like this, then the circuit diagram will be like this. This is the point A. And keep the point B like this only. So this is the point B. I'll take it as R, R, R and R. And I will take it as, for example, 5R. Then the bridge is balanced. If the bridge is balanced, okay, if the bridge is balanced, then we can neglect the middle part of the resistor. Now, if the bridge is balanced, then we can neglect the middle part of the resistor. Okay, for example, if the bridge is balanced, then we can neglect the middle part of the resistor. If you neglect the middle part of the resistor, again, all the four resistors are R, 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 and R. Then what is effective resistance? Means effective resistance is R only. That's it. Okay. So if you're done with this, you may leave the class. Tomorrow there is no class for you. I'll conduct a test on both the first chapter and second chapter. So tomorrow there is no class. I'll conduct a test on first and second chapter. Same I will upload in the app. So whenever you are free, you can write the exam. And Thursday, I will explain about the meter bridge as well as potentiometer. That's the end of this chapter. Then we'll do the problems again on these topics what we discussed. Okay, students?
Okay, sir.
Yeah, fine. So copy this and you may leave the class.
Thank you, sir.
Thank you, sir.
Yeah, yeah.